Summation to integral calculus. Okay, so we are pursuing discussion summation to integral calculus. Summation to integral calculus. Okay, we will revise something and then we will take the length vector to calculate the volume of a sphere. Okay, through the independent component r theta phi in the plane of x, y, z. If I have Cartesian coordinate x, y, z and r theta phi is a spherical coordinate and they are independent in x, y, z coordinate system, then can we calculate with the triple dot product of the three length vectors, and then we will calculate the ith, jth and kth section, and then we will go to integral calculus. Okay, what is summation to integral calculus? What is summation to integral calculus? If we look very near about what is summation to integral calculus is to to break the problem into n number of parts, calculate the solution part by part and add it. Calculate the solution part by part and then add it. There are many concepts here bringing summation to integral calculus. Okay, what are these concepts? So if anyone is trying to divide problem into n number of parts, then this is typically called discrete part. This is typically called discrete part. Okay, one example, hope, gone. Okay, okay, one example that we have been giving, I believe we have talked it earlier also. What is the example is, consider this is a unit length stick. The stick is unit length. If the stick is unit length, then okay, I cut this stick at any part. The chance of cutting the stick at any part is same. There is no partiality that I'll tend to cut the stick in the first part or second part. This stick has a length of 1 unit. 1 unit can be 1 meter, 1 centimeter, whatever it is. The stick length is 1 unit. If okay, if stick length is 1 unit, now I'm going to cut stick into a part. Okay, if I cut this stick into two parts, I take some knife and I cut it into two parts. Okay, consider this is the length of the cut. This is the cut, right side cut I am throwing it. Right side cut I am throwing it. This is, I cut it from here. Left side I keep it. What is the length of this cut? Makes sense? What is the length of this cut? Then I take another 1 unit length stick. I throw it. I measure how much it was. I cut it again at random and take the left part. That is the x distance from the origin. If this is origin, this is x axis, this is 1. I cut at any position and x is the distance from the origin. Okay, I keep doing it. I keep cutting it. Okay, I cut it, measure the length, throw it, take another one. Cut it, measure the length and throw it, take another one. Cut it, measure the length and throw it. Make sense? Okay, if that is the case, then what is the average length of the stick? Okay, question is not clear. If there is a stick of length 1 unit and I cut the stick from any position, make it into two parts. The left part I am measuring the length, or left part I am throwing in one direction and right part I am just discarding it. Then I take another stick, cut at any position. Left part I keep in a garbage. I'm sorry, keep at one side. Right side just discard it. Take all the stick whatever I have. all the stick. Okay. Now in that fashion, now wherever I have collected the cut part, the left part, now measure the length of all the part and say what is the average value of the length. That is the question. What is the average value of the length? Okay. It is similar to like if I take a class, there is a class, students are studying in the class, and in that class I have marks. Okay, in that class I have marks in a way that this a student can get 1 mark, 2 mark, 3 marks out of 10. Makes sense? There is a 10 marks, there is an examination that is held in the class, and examination is marks is maximum 10 someone can secure. And in 10 marks there are kind of consider there are 10 students in the class, and there is a maximum they can get 10 marks. Okay. Now I take one student and ask how much marks you have secured. Then he is saying I secured 4 marks. I cut at the 4 right side, I leave it, and whatever is there I throw it, I keep it. Next student I ask, or there are innumerable students are there. Each student marks I am asking, and he is saying I got 9 marks. Then 9 length I keep it, 1 length I cut and throw it away. 9 I just keep it. Now if I have all the sticks with me, then what is the average marks of a student? That is the question now. Now I have to measure the length of all the stick and divide by number of the student. Then that is called average mark. Makes sense? Okay, in the previous question I had asked that if there is a 1 unit length stick and I cut from any point and left part I keep it. If I measure all the left part length and then divide by number of the stick, I get the average length of the stick. Cut stick. Makes sense? Okay. Now let's take that what would be the average value of the kind of average value of the student marks. Someone would say just add all the marks. That is the you did a cut, right? If mark is six, then you cut 6 length and right side you throw it away. 6 length stick you keep it. This is what you mark the marks of the student. Then measure the length of all the stick, whatever marks they have got, divide by number of the student. That is one way. What is second way? Second way here is that now draw a line now. This is x-axis. Okay. Now how many students they have got 10 marks? Consider there are n number of students are there, or there are alpha number of students are there. This is 0 to 10. How many students have got 10 marks? Okay. Now measure it. Consider that there are number of students. I said that they are, consider they are 20. Marks is 10, number of students are 20. Now in 10, two students got 10 marks. Two students got 10 marks. Okay, 10 students got 5 marks. Make sense? Okay, 6 students got 6 marks. Okay, 2 students got 4 marks and 1 student got 7 marks. I believe it is all right. Okay, two student got 10 marks. 10 students got 5 marks, 12. 6 students got the 6 mark, 18. Okay. And 1 student got 7 marks and 1 student got 4 marks. I believe it is all right. 2 students got 10 marks. 10 students got 5 marks. 6 students got 6 marks. 1 student got 7 marks. 1 student got 5 marks. Okay. Now tell me the average mark. Now how many students are there? Number of students are 20. Okay. Number of students are 20. It can be said alpha, but right now it is 20. Okay. What is the probability of a student among the student getting 10 marks? 2 by 20. Out of 20 students, 2 student is getting 10 marks. Probability of a student getting the 10 marks is 2 by 20. Makes sense? There is a bar. There is a bar at 10 mark. Height is 2 by 20. There is a bar at height 5 at point 5 and height is 10 by 20. 1 by 2 that is height. Here 2 by 20 is less. 1 by 10. Okay. At 6 it is 6 by 20. 7 1 by 20 and at 4 1 by 20. 1 by 20 1 by 20 6 by 20 10 by 20 and 2 by 20. Okay, now take the 4. 4 probability is 1 by 20. 1 by 20 into x plus 5. 5 into 10 by 20 plus 6 into 6 into what is height here? 6 6 into 6 by 20 plus 7 into 1 by 20 plus 10 into 2 by 20. If I add like this, then it gives the average mark. Okay, what is formula here? If I this means slowly we are coming to a kind of modeling the data. Whatever data we are modeling it into some kind of equation and data structure. Time to time. What is the now can I make it shorter? That was bigger. Cut it, take a stick, cut at the mark location, take the from left and keep it. Take a stick, now assemble all the stick, measure the length and average it. Now you have only one stick now. And there you draw the bar chart and then you add like this. Then you write like this 4 into 1 by 20 plus 5 into 10 by 20 plus 6 into 6 by 20 plus 7 into 1 by 20 plus 10 into 2 by 20. If you add all this, then you get what is better way? Summation. Summation I equal to 1 to 20 because summation, I'm sorry, summation I equal to 1, I'm sorry, summation I equal to 0 to 10 because marks is from 0 to 10. What I am trying to find? Average mark, not average student. Average marks I am trying to find. Summation, sigma sign. Summation I equal to 0 to 10. Okay, I equal to 0 to 10. X of the ith section. X is the marks. X of the ith section. Probability of the fx. I will rewrite this. Sigma I equal to 0 to 1. X I is subscript. X bottom right x I into function over x of the ith section. What is I? Looks like I'm dividing my 10. I'm dividing this kind of this mark section in 10 parts. In 10 parts. Okay, this is the first part 0 to 1. Okay, like this there are parts 0 to 1, 1 to 2. Like last part is 9 to 10. Last part is 9 to 10. Okay, now but okay, consider the student get marks from 1 to 10. No one is getting 0. Okay, in that fashion now it works. Now I have divided this my stick into 10 different parts. 0 to 1, 1 to 2, 2 to 3. These are part number 1, 2, 3, ith part. And then we have at the end that is 10th part. I'll rewrite it. Summation I equal to 1 to 10 now. I denote the part number. I equal to 1 to 10. X of the ith section, that is a mark, function over x of the ith section. What is x? X of the ith section. First section x is 1. Second section x distance is 2. Third I is x is 3. Okay, these are the marks. What is function over x? Function over x is the probability. When marks is 1, what is the probability? Marks is 2, then what is probability? Now I can write in one go. Summation I equal to 1 to n, where I talks about the ith section. I equal to 1 to n, x I subscript, bottom right, x I, function over x I. This is called modeling of the data. Means whatever data we have, we are modeling it now. This is the average mark. This is called summation. We divided our problem into n number of parts. No. How we divide problem into n number of parts? Marks is 1, 2, 3, 4, 5, 6. Consider that a student is getting marks in any fraction. Someone is getting 0.5, someone is getting 0.75, someone is getting 5 miss. What I'm trying to say that the marks that a student is getting, that can be innumerous number of marks possible. Makes sense? There is an innumerous number of marks possible, not 1, 2, 3, 4, 1.5, 1.25. This is what the examiner is granting the marks. Now, if I take the stick and cut where the student is getting the mark, I can cut anywhere, not at the discrete level. I can cut anywhere. Makes sense? What is the average mark? Then we cannot say I equal to 1 to 10, because marks can be infinity. Marks can be infinity. Okay, now I can say loosely that this is a marks that is 0 to 10. Let's divide it into n parts. Makes sense? Let's divide into n parts. 0 to 10, let's divide it into n parts. Let's divide it into 10 parts. First we'll go with that. Let's divide it into 10 parts. Then summation I equal to 1 to 10 x of the ith section. Okay, how much is the mark that we talk about in the ith section? Okay, that marks is between x of the ith section, function over x in the ith section. Makes sense? If I am talking about a section 0 to 1, then x will be 1. X of the ith section will be 1. Means number of student marks is 1, but mark can be 0 0.1, 0 0.2. I am taking it as 1 because I divided it into 10 sections. So everyone who is getting from 0 to 1 marks, I am considering it as 1. So I am saying, because I have divided the marks section into 10 parts, only in 10 parts. A student can get marks only in 10 parts. No, my student has got 0.25, consider it as 1. A student has got 5.75, consider it as 6. A student has got 10, a student has got 9.1, all are same. Because I divided my problem into n parts. Problem is in infinite parts. Because students are getting any marks, I want to find the average mark. To get the average marks, I'm dividing my problem into n number of chops. This is called dividing problem into n parts. Now I'm trying to find the solution. Summation I equal to 1 to n xi, function over xi. Function over xi says how many, this is the marks and vertically number of the student. If I say between 5 and 6, 5 and 6, at every section, if 0 to 1 is there, then there is a bar chart. 1 to 2 is their bar chart of the student. 4 to 5 bar chart of the student. Okay, 5 to 6 bar, how many students are there in 5 to 6? Okay, now if there are 10 students getting the marks, 10 students getting the marks between 4 and 5, between 4 and 5 means not including 4, excluding 4 and including 5. Between 4 and 5, 10 students are getting marks. So 4 and 5 in that section, that is considered as the fifth section. There the height is 10 by 20. Now I am writing it. Summation I equal to 1 to n x of the ith section, function over x of the ith. Function over x is the height, means how many students are there in that fashion. This will also give the average mark. This is called, I divided a problem into n number of parts and I am trying to solve it, because consider that there are there are kind of 1000 students are there and they are getting this. Then if I draw for each point a bar chart, then it will be very difficult to find. So in that fashion, I divided into n parts. I am trying to model it. Okay, now someone would say this result is not accurate. To make the result accurate, now I am increasing the n. First, I made it under my control. Once control is achieved, then I am increasing the n. Now n is 20, n is 40, n is 100. Consider n tends to infinity. Consider n tends to infinity, means between 0 and 10 marks, I am dividing it into infinity part. Okay, and at each point I have function over x. At each point I have function over x. Makes sense? At each point I have function over x and multiplied by this x. Okay, now if I do so, then I can rewrite it. Now summation I equal to 1 to n x fx. Now it is very difficult to calculate. Consider the students are 100,000 in number. That is not possible, but consider like that. Okay, if they are in 100,000 in number, how it's possible? N more or less n tends to infinity. Number of students are infinite, like some board examination. Any board, like in India, someone is calculating the average mark for particular board examination. There are innumerous students are there. I'm trying to calculate the average marks. Okay, now if that is the case, then how someone can solve it? Okay, two fundamentals comes into the picture here. One fundamental is that you have the height at every point. You have the height at, now I'm going little bit different, but we are trying to come to a solution called integral calculus. Now consider that this is the mark section. This is the mark section, and at each mark there is a height. Height is number of a student in that mark section. Okay, if consider I have an expression like this, summation I equal to 1 to n function over x. Consider something like summation I equal to 1 to n function over x. Make sense? I equal to 1 to n function over x. What is I equal to 1 to n? If I have 10 marks, then I divide into n number of parts. In each part, how many students are there? Probability. I'm going with probability. How many students are there means if in each section one section is of length 10 by n. If there is a 10 marks is there and I divide into n part, then each section has a width of 10 by n. In 10 by n width, at a distance from here to here, that is the marks, in the ith section, how many students are there out of the total students? That is the bar chart. Consider I am adding fx. Leave the x part. Average marks I am just leaving it. Just leave it. Summation I equal to 1 to n. Summation I equal to 1 to n function over x, where x is in the ith section. What would be the distance? If this is ith section, the distance is 10 by n. 10 by n into I. If this ith section is n, then 10 by n into n. Distance is 10. If ith section is 1, then 10 by n into 1. That is the distance. That is the x, whatever it is. Now, someone can say, can you measure it? Summation I equal to 1 to n function over x of the ith section. Someone would say, very difficult. It is very difficult. Is it in some function real? Yes, it is in some function. What is the function? Consider this someone would say this is in sinusoidal function. This is in sinusoidal function. Okay, what is sinusoidal? Absolute of the sinusoidal function. What is absolute of the sinusoidal function? Okay, absolute of the sinusoidal function means that at the beginning the number of student is 0 at the 0. The number of students go maximum at pi by 2. Then they come to 0 at pi. Then absolute I have taken. Then they will go again up and they at 2 pi. Pi is 3.4, 2 pi 6. Then again they will go up like this and up to 10. This is the distribution of the students. Means at pi by 2 maximum of students are there. They decrease, then they increase, decrease, increase. This is the distribution of the students. Okay, so fx is sin x. Yes, fx is sin x. Okay, whatever it is. Can you calculate summation of I equal to 1 to n fx? Fx can be sin x. Fx can be Gaussian distribution also. 1 by square root of 2 pi into alpha e to the power minus 1 by 2 x minus mean whole square, x minus mean whole square by the standard deviation whole square, sigma whole square. 1 by sigma into 1 by square root of 2 pi e to the power minus 1 by 2 into x minus mean whole square by sigma whole square. This is the distribution as a Gaussian distribution. There is another distribution called sinusoidal. This is what I am talking. What is distribution? That is sin x modulus. Sin x modulus means it will go, it may not be the valid distribution, but for simplicity I am saying. A student will go like this, come back like this, go like this, come back like this, go like this, come back like this. If I talk about the Gaussian distribution, then we have to find where the mean is. From 0 to 10, where the mean is. If mean is here, then it will go up like this and then it will go like this. These are the distribution of a student against each mark. So someone would say, I'm trying to find a summation of I equal to 1 to n function over xi. What is n? N is 200. Sorry, not possible. I'm not going to calculate 200 summation. What is n? 1000. Absolutely not possible. Absolutely not possible. You're the number of a student at each point in the, there are n sections you have done, right? 0 to 10. If I take any board examination, then there are crores of students they appear in particular board exam. Crore means millions of students they appear in the examination. If I talk about the number they are getting, number can be anything between 0 to 10, anything. Okay, now I am to what I want. I want to calculate the kind of I want to draw the probability density. Probability density, if I draw, I'm sorry, this is called probability graph. At each marks, how many students are there? If I add all the probability, it will come as 1. Okay, it will come as 1. Now, someone would say, can you verify it? It will come as 1. Summation I equal to 1 to n means I chop that 10 marks into n part. Actually, there are infinite because students are in crores in number, infinite. But I divide it into n part. Each part, I am drawing a probability bar. How many students are coming in one bar, section, and what is their height? Now I am adding it. Summation I equal to 1 to n function over xi. If I add all, then if I divide into 10 parts and then if I add all, it should come as 1. N can be, what is average mark? I have to multiply it by xi. That is the average mark. Average marks is summation I equal to 1 to n x of the I fxi. Right now I am leaving the x part fxi. Or someone consider x into fxi some other function gxi. Right now I am taking fxi. Just leave the x. If I have all the bar, then can I bring it into integral calculus? If n tends to infinity, summation of I equal to 1 to n, function over x is a sum function. That is guaranteed. Can you add it without, if n is 10,000, if n is 1 million, if n is 1 billion? Not possible. No one can add straightforward. Summation I equal to 1 to n function over xi. Not possible. Even 1000 is there. It is difficult to take f1, f2, f3 for the function. What is the height for the first section, second section, third section, fourth section, fifth section, sixth section, seventh section, up to 1000 section added. If n is infinity, not possible. Then this is called, first it is called summation. First is called summation. Can I bring this summation into integral calculus? Why it is needed? I believe it is understood. Why I am calculating? Suppose I am calculating the average marks of the board examination. what is the average mark a student has got? That is summation I equal to 1 to n xi function over xi. That is the summation I am calculating. And if n tends to 10,000, no one can calculate. Not possible. Okay, what is the solution? But we brought the solution, we divided our problem, that is 0 to 10, into n parts. That is for sure. We divided the problem into n parts so that it should be simple. Like I divided the problem into 5 parts only. 5 parts. What is 5 parts? 0 to 2 marks, how many students are there? 2 to 4 marks, how many students are there? It is simple now, right? 0 to 2, how many students are there out of all the students? Just multiply it by 2 into height, plus 4 into height, plus 6 into height, plus 8 into height, plus 10 into height. Okay, height is the probability, not the actual number of students. Number of students in this section divided by the total number of students. Okay, this is the average mark, but this is not accurate, boss. This is called dividing the problem into n parts. If I have a problem to find out the average marks of a student, then I take a x-axis. How many marks are there? 0 to 10. Divide it into 5 parts. 0 to 2, 1 part. 2 to 4, 1 part. 4 to 6, 6 to 8, 8 to 10. Now tell me how many students are there in 0 to 2 part. Okay, in that alpha students are there. How many students are there actually? Beta students are there. Alpha by beta is the height of the section 0 to 2. 2 into alpha by beta plus 4 into whatever the bar is, plus 6 into whatever the bar is, plus 8 into whatever the bar is, plus 10 into whatever the bar is. Just add it. This is the average. But boss, all right, you divided the problem into 5 parts and you solve it by adding it. Thank you. So summation I equal to 1 to n xi fxi. This is what you did, right? Where n is 5. You divide it into 5 sections. Okay, I'll make it better. Let's take n as 100. Then it will be even smoother. Okay, if n is 100, then first section length will be 1 by 10. If it is 0 to 10, and if I chopping into 100 section, first section will be 1 by 10. 1 by 10 into whatever your probability was, plus 2 by 10, what is your probability was, plus 10 by 10. Now we have come to up till 1. 11 by 10, 99 by 10, 100 by 10. Then you add it. Okay, sweating, but still it is not dividing the problem into n part and solving it. This is okay, still it is not accurate, but we are reaching the accurate. What is accurate? N tends to infinity. That is accurate. Now I chop this number section 0 to 10 into n parts, and then I write I equal to 1 to n xi. Xi is the distance from here. Xi function over xi, and for each part you get the xi value and function over xi value. Keep adding it. N tends to infinity, not possible. Okay, I solved it by dividing the problem into n parts, but I can solve only when n is manageable. 5 part, 10 part, 20 part, up to 100 part, I can sweat and I can measure it. But that is not accurate. To get the accurate, so first is solving the problem by dividing into n different parts. Solve. Okay, then to go for accuracy, to be best accuracy, n tends to infinity. If that is the case, n tends to infinity, then next step is to bring it to integral calculus. Okay, to bring it into integral calculus, then you will find the solution. What is the integral calculus? Integral calculus is when the number of, first we divide our problem into n parts, okay, and then try to find the solution. To get the accurate, n tends to infinity. If n becomes infinity, repeated summation will come to integral calculus. First you find the repeated summation through the controlled n. What is the controlled n fashion? One controlled n is there, then make n tends to infinity. Now how to bring this repeated summation into the integral calculus? Okay, that is next part. Now I'll rewrite as summation I equal to 1 to n xi function over xi function over xi. Okay, Now function over xi, if I take function over xi, okay, that is a discrete value. That is for one section I have one bar, 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 one section I have one bar. Okay, and that I am multiplying with the beginning to give the average result. Okay, what is integration? What is integration? Let's say I write something called fx dx. Consider, I write something as fx dx. This is called integration. What is the basic form of integration? Fx dx, limit of x from begin to end, is called integration. This is the, what is summation? Summation of I equal to 1 to n and your function is summation. What is integration? Limiting x from 0 to, from begin to end, fx dx. This is a basic form of integration, where this is x-axis limiting from 1x or 0 to some other point. Here other point is 10 and one point is 0. 0 to 10, limit is 0 to 10, function over x. Consider this is function over x, vertical is function over x. Vertical is function over x and this is x. If I have a graph like this graph is continuous. Earlier we had height. If I say I have a graph called function over x, if this is x-axis, then there is a graph called function over x. This is continuous graph. What is the continuous graph? If I take any x, then if I calculate fx, that is the height. If I take any x and calculate fx, that is the height. It is same as what we did earlier. If I take any xi, not x. If I take any xi, then I have fxi. You have height, but height is granular. It is discrete, and one height is only possible. Only one height is possible in one section. If you divide in n section, only one bar is allowed. Here, if it is continuous, then it is infinite x is possible, and there we have vertical. Okay, what is fx dx? The area underneath it. If I draw a fx graph and if I say fx dx from 0 to 10, then if this graph is there, and if I calculate the area, it is same as fx dx, x is 0 to 10. Okay, what is greatness of fx dx? You have x infinite x. This is what we want, infinite x. Yes, we want infinite x, not n tends to infinity. Marks can be in any region because there are so many students are there. So we want infinite, yes. So fx dx, where x can be anything. Fx is height, dx is the x, whatever it is. The fx dx, calculate the area underneath it. If you bring your problem of repeated summation to area, then integrate, you can convert into integration. What is area? Area means if you have fx, that is the height, if you multiply by some width, it is area. So if you say that I have a function like this, then if you take any point here, height, and you multiply by the width, then you get this subsection. If you calculate the area of subsection, like if I divide into n parts, this is x-axis and I divide into n parts. In any part I have fx of the ith part. If I divide it, if I multiply with the width, I get the area of this strip. If I add all, I get the full area. Now I can write it is same as fx dx. What do you mean? What I mean is, if I have summation I equal to 1 to n fx, can be converted into fx dx integration? No, because you have only the height, not the width. You have to multiply by the height by the width so that you get the area strip. If you get the area strip, then you can add all the area strip like summation. Then what I can do now? Okay, I have summation I equal to 1 to n fxi. It should be fxi delta xi, because you have to multiply by the delta x. Then only it will get area of the strip. Right now you have only the height. Then what I can do? Okay, rewrite it now. Now you have summation I equal to 1 to n fx, right? Fx. Consider fx equal to gx dx. Gx dx is the integration sign, right? Gx dx is integration sign. Okay, if gx dx is integration sign, then what is, I'll rephrase this. Now I have now in discrete manner. What is the problem? I have problem summation I equal to 1 to n fx. I am leaving x part x into fx for average mark. Leaving x part fx fxi. Fxi is I have summing, that is the heights. I am summing it. But I am in problem because n tends to infinity. It is very difficult now. How can we get into calculus? So that for calculus there are pre-made formulas are there for different kind of fx that are ready-made available. Quickly I can calculate. To get the calculus, you have to have area, but you only have the height. So every height should be multiplied by delta x so that you get the area strip. Then you add summation I equal to 1 to n fxi into delta xi. Then it can be converted as fx dx x, not I, x from begin to end. Because at the end you are calculating the same. But I don't have delta x. Okay, if you don't have delta x, then you can imagine something like that. That you have to get delta x. But if I get delta x, if in each section I have the height, that I know. But if I multiply, if I introduce delta x, then both should be same. Makes sense? Consider the new height, then height will reduce. I mean, height will change. I rephrase this. Now I have a mark section, and mark section is divided into n part. Each part has a width. That is, if marks is 0 to 10, its width is 10 by 10 by n. Their number of student probability is the height. Okay, if this height is the summation I equal to 1 to n fxi. But if I'm not able to calculate it, to get it, I want integral calculus. To have integral calculus, it should have been like summation I equal to 1 to n fxi delta xi, where delta xi is the width of that section. That is 10 by n. Okay, if width is constant, not required that width will be constant for the each section. But right now it is 10 by n. But if I multiply by 10 by n, then my fx will change. Okay, then it will change. What we can do? So right now you have fxi, right? Now fxi, now you have to place it as fxi delta xi, but we cannot write like this. So fxi will change. What you want? The solution is fxi equal to gxi delta xi. Now I have to introduce fxi as gxi delta xi. Then only it will become integral calculus. Okay, fxi equal to gxi delta xi means gxi, that is a new formula I am getting, that is dfx by dx. So summation I equal to 1 to n, where n tends to infinity, fxi will become gxi dx delta xi. That gx fx will renamed as gx, and it will be different. How much it will be different? Gx dx delta x equal to fx. Dx is equal to dfx by dx. If fx is sin x, then cos x, then it will come as cos x dx, whatever it is. So now we have reframed the problem. What the actual average mark is? Average mark is summation I equal to 1 to n xi fxi fxi. Now fxi becomes gxi delta xi, and that is settled as fxi equal to gx delta xi. Gx become d, then gx will become fxi by delta xi, dfx by dx. Now this can be brought up into integral calculus because we have delta xi. Delta xi is the width and fxi is the height. This gives the area of this section multiplied by the x. Now this can be brought into integral calculus. What is the now average mark? Average mark is integration x equal to 0 to 10 x x x gx dx. Makes sense? First you have to find fx through what formula? Fx is there, but fx is random, right? A student are getting random. You have to put in some formula, either Gaussian distribution, and there are so many distributions are there. See which is the nearest matching distribution. Okay, Gaussian, Cauchy distribution, and gamma distribution and alpha distribution. So many distributions are there. You have to try to match to some distribution that you get fx. Now you have to find gx so that gx equal to dfx by dx. Now you write like this: integration x equal to 0 to 10 x gx dx. One go, you get the average mark. This is called some. First, you find the summation, that is n, then make n tends to infinity and break it into integral calculus. Do you have any other concept here? Yes, we have. Consider I need to find summation of 1 by 2 to the power k. Summation k equal to 0. Summation k equal to 0 or summation I equal to 0 to infinity. Makes sense? Summation I equal to 0 to infinity 1 by 2 to the power I. I believe it is all right. Suppose people will say, I know, solution I know. What is your solution? Consider S equal to summation I equal to 0 to infinity 0 to infinity 1 by 2 to the power I, right? That will come as 1 by 2 to the power 0, that is 1. 1 plus 1 by 2 plus 1 by 2 whole square plus 1 by 2 to the power 3, like that. That is, consider that is S. Now multiply S with 1 by 2. Now we have 1 by 2s. S equal to 1 plus 1 by 2 plus 1 by 4 plus 1 by 8, like that. Now multiply it by 1 by 2. Now it will become 1 by 2 plus 1 by 4 plus 1 by 8, like that. Now subtract it. Now we have s minus s by 2. This side and that side, since it tends to infinity, then it will remain, only 1 will remain there. So half of the s equal to 1, s equal to 2. The net summation is 2. Can we tackle it through integration? Okay, I tried it. So what we have to find? Summation I equal to 0 to infinity and then 1 by 2 to the power I. What we are getting? Now we have x-axis and now the I equal to 0. We have divided into n number of parts. We have divided into n number of parts. N number of parts if we have divided, then I equal to 0. The first 0, when I equal to 0, then it is the height is 1. I equal to 1, then height is 1 by 2. I equal to 2. Consider that these parts. I equal to 2, then height is 1 by 4. Height is reducing. It starts from, or consider that I'm trying to find summation I equal to 1 to infinity 1 by 2 to the power 1 by 2 to the power I. Now it is better understandable. Now we have first section, second section, third section, fourth section. So first section is I equal to 1, means in the first section height is 1 by 2. Rather than starting from 1, I am starting from 1 by 2. So I equal to 1 to n, where n tends to infinity, 1 by 2 to the power I. Calculated. Now the first section, ith section, first section height is 1 by 2. Second section height is 1 by 4. Third section height is 1 by 8. 1 by 16, like this, tends to infinity. Calculate the integration. Okay, I believe this can be an assignment to find the summation through, this is not there in any of the books. Anyone can try. What is summation I equal to 1 to n, 1 by 2 to the power n, where n tends to infinity. I'm sorry, summation I equal to 1 to n, 1 by 2 to the power I, where n tends to infinity. Find it through integral calculus. Okay, this is repeated summation. Okay, we will see it. Integration way is not there in any of the book. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number. Okay, how to find it? You have to bring it into fx delta x. Then only you can bring into calculus. Here delta x is luckily 1. So delta x is hidden there. Anyway, we will say it.